Animating math, the Riemann sum. So, without further ado, let us begin. The Riemann sum. Let f be a function defined on the interval a to b mapped into the real numbers and p be a partition on that interval. When we partition the interval into endpoints, we obtain subintervals. And the Riemann sum defined on f over the interval is defined as follows. We're going to evaluate the function within each subinterval and take the width times the value of the function evaluated, and then we're going to add up all the areas. The width is just the distance between the points of the subintervals, and typically we'll consider it equal, but it can vary. And the function that's evaluated, it's evaluated within each subinterval. The Riemann sum has three different types. The left Riemann sum is when we evaluate the function on the left subinterval. The right Riemann sum is when we evaluate the function on the right subinterval. And we could take the middle of each subinterval, and this is called the middle Riemann sum. There are other methods as well, such as the trapezoid and the upper and lower Riemann sums, but we will just consider these three methods. The most common partition is to take equal subintervals and we just add common width, where the width is b minus a divided by n, where b is the right endpoint, a is the left endpoint, and n is the number of subintervals. The right Riemann sum of the function 2x times e to the negative x squared can be obtained by partitioning the interval 0, 4 on 40 subintervals of equal length, and let's recall that the width of each subinterval is just the right endpoint minus the left endpoint divided by the number of subintervals, which is 4 minus 0 over 40, which is 0.1. Okay, so we're just going to evaluate the function within each of the subintervals, and because it's the right Riemann sum, we evaluate to the right of the subintervals, and then we're just going to add up all the areas. This is a visual demonstration of the right Riemann sum. We can increase the number of rectangles, which decreases the width of each rectangle to asymptotically approach the definite integral of that function. Thanks for watching, and remember to subscribe to my YouTube channel.